Ooh-wee, this video is going to be a good one. We have some of the best componentry I've ever got my hands on, and we're going to be installing it onto the best 3D printer platform that I've ever gotten my hands on coming out of China. This is the TwoTrees Sapphire CoreXY 3D printer. For those of you who saw the last video, you know how highly I think of you. Now, the #1 negative comment on that video was a criticism about the fact that the bed will fall when the torque current is cut on that stepper motor. And I have no idea why the Lurge board cuts that torque current, and I have no way to change that because they don't let you into the nuts and bolts of the firmware. The Lurge board is completely closed source and locked down. Fortunately, this should be a very easy problem to solve with just a $2.50 anti-backlash nut. So I think that will solve our falling bed problem, and print resume on power loss will work perfectly after we're done with that. On top of the Mosquito Hotend and the T-nut to install, we're also going to play with this print surface. This is a glass bed with the beads that help the print detach after it cools down. I've already installed this magnetic bed surface, so I'll show you guys how I did that as well. And we're gonna put a BLTouch on it. And finally, we're gonna put a new belt on there. 2 new belts actually. And that's not an upgrade, that is to make up for a small mistake that I made when I was assembling the thing. So lots of stuff to cover. This should be a great video, and when we're all done, I think we're gonna end up with the absolute best consumer level 3D printer, single color, single filament that you can get. So I'm really excited. Let's roll that intro and get into it. I want to talk about a guy named Shay Shen. Now, a comment in the last video told me that he is the designer responsible for the TwoTrees Sapphire CoreXY 3D printer, the Tevo Little Monster Delta style printer, the Tevo Tornado, as well as the Tevo Black Widow, and I think there's a couple of other designs out there that are his as well. So clearly, this is one talented engineer. I think he is the best 3D printer designer coming out of China, and that includes all of Creality's products. The stuff that he designs is better than what Creality's making. Now, Creality printers are in fact probably a better purchase than his designs just because of build quality. But Creality's whole sort of mindset is a race to the bottom. How cheaply and simply and inexpensively can we make this thing and then deliver just completely reliable, good quality straight out of the factory every time. So, none of these Chinese printers are doing their own testing in-house. They sort of rely on us to do the testing for them, and then they adjust and they make a new product next year. So they're all sort of avoiding paying that burden. They don't have a testing R&D department. They just have a designer who designs the machine based on his intuitions, which is what we're all doing as hackers. And there are many, many talented engineers in the West who don't have access to Chinese manufacturing. And that means, unfortunately, that the products are going to be more expensive because they're manufactured in the West. But they're oftentimes better, way better, in fact, than the Chinese equivalents. So what would be ideal is if we could get kits that didn't include the things that we want to upgrade to. For instance, the Duet control board. Why can't we buy a 3D printer kit from China that does not include electronics? The closest thing we have is Creality printers, which come with that extremely inexpensive control board, just the cheapest thing you can imagine. And so that's nice because you're only losing out on like $15 worth of your money. You only paid $15 for that part that you're going to throw away when you upgrade to the much better control board. Unfortunately, that's not the case with the TwoTrees. This one comes with the Lurge control board, which we're going to be seeing more and more on the printers coming out of China. And I'm really not a fan of this control board. It's closed source, completely closed down. You just can't access a whole lot of features. For instance, you saw what happens when the bed falls, right? Even though the machine was on, the bed would fall. So I would love to get in there and change the parameter that shuts off the current to that motor after like a 2-minute idle. I would love to have it so that it never shuts off hold current to that motor as long as the machine is on. And that way that bed would never fall. But that's not something that you have access to if you get a Lurge control board. I mean, contrast that with the Duet board or a Marlin control board, where you can get in there and just completely adjust the firmware to do whatever you want it to do. You have full control over your machine. Now I'm bringing all of this up because I was in communication with some of the folks there at TwoTrees, and I asked them for a bare bones kit, one which did not include the hot end, the control board, or the geared extruder, because that's just kind of too close to the E3D design for my liking. It's getting into knockoff territory, even though it is an upgrade. It's better than the E3D design, but it's too much of a knockoff for me. So, you know, that would be awesome to get that kit and not pay for anything that you're not going to use. And I think TwoTrees would sell a whole lot of those kits, but I get the feeling that China is kind of, you know, an insular place. There's kind of some cronyism. They kind of help each other out. They're all in the Chinese Communist Party together, however it works, and they're not interested in selling a bare bones kit which will help Western companies to sell their products. Because if you look at it, there's really only one Western 3D printer company making a frame, and that would be Prusa. So how great is it that all of these Western companies are making upgrades for the Chinese printers, but why doesn't a Chinese printer manufacturer sell a kit that you can then upgrade with the Western designed components, which are superior to the Chinese versions? For instance, hot ends. E3D, Slice Engineering, and Micro Swiss all make superior hot ends to anything coming out of China. So there's 3 Western companies that are doing a better job, and we're all upgrading to those hot ends anyway, so why doesn't China just sell us a printer without a hot end to begin with? All right, that's the end of my little rant. Let's get back to the positive stuff and make an awesome 3D printer. We'll do the easy upgrades first, starting with the bed. Now, I already installed this magnetic bed surface. Don't believe what they tell you on the internet. Apparently, the maximum temperature you can print on these things is 80 degrees. That's not true. You can run these things at 100 degrees without any issues. As long as you don't abuse it, meaning you do not want to run a hot nozzle colliding with this bed. That will ruin these beds because they are soft plastic. Glass, on the other hand, like this bed, is much more forgiving. You can make all kinds of mistakes, be pushing that nozzle, dragging it along the bed, and as long as the glass doesn't break, I've never broken one of these. Probably a better bed surface as far as just longevity is concerned, but being able to peel this off and pop prints off sure is nice, except that when you have a print that goes edge to edge, it's still pretty hard to remove this. It sticks pretty well at that case. So the glass bed might actually be superior for large parts. I am going to use this new PCB that TwoTrees sent me in the box. Unfortunately, this new PCB has 4 holes, 1, 2, 3, 4 holes drilled for the mounting, whereas the one that I have right here has only 3 holes. 1, 2, 3 mounting springs. See that one in the back there? So that means we're going to have to drill 2 holes in the back corners in this sub bed. And then we'll be able to compare print surfaces. This is that glass print surface with the like etched dots. Let me tell you guys real quick how I installed this magnetic bed, because it is important that they stay aligned. So you can see that I have a little bit of an offset on all edges. And that is because this print bed was designed to work on an Ender 3, which has 230 millimeter bed, whereas this is a 200 millimeter bed. So I could have just lined up the template, that's the print surface that came with the machine. I could have lined it up in a corner and cut off 20 millimeters off either end. But that would have been problematic because there are little print zones, like little dots of magnetism, and they have to line up in order to get this bed to sit on there just right. So what I ended up doing was using this original print surface as a template, and I just cut out of the center. I sort of just traced the edges and cut out of the center on the magnetic portion. So yeah, that's how I got that installed, and then just stick it down and everything's good. So we'll be able to test that after I drill the holes for that one, and we'll be able to swap back and forth between the 2 PCBs. I got this magnetic viewing film, and we can see the lines. See the lines coming through in the magnetism? See the little stripes? So that's just the way the magnet is laid out inside the rubber, inside this bed. You can definitely feel the way that it lines up to this bed when you try to pull it against those things. There's this, it's like skips. There you go. It skips So it's got zones for sure. So I think every other one of these lines must be a North Pole and a South Pole. And so it's got to skip 2 lines per slide. So after installing the bed, we're going to move up here to the top of the printer and we're going to do 2 tasks that involve sort of semi-disassembling the frame. The first task is we're going to install the anti-backlash T-nut right down there where the T-nut mounts into the sub bed. And the next task is to relocate the belt mounting points. And so unfortunately I cut these belts too short, so I can't extend them the way that I need to, which is why I got myself all new belts here for this machine. And what you need to do is, don't make the mistake I did, you want to mount this zip tie. See how it loops back around and zip ties to itself? You want to mount that over here, and you want to mount this one over there. And that way the zip ties will not be getting in the way of the pulley. See how that zip tie collides with the pulley? And that is what's limiting me from being able to print all the way to the edge of the bed. I'm basically only able to print to like right there maybe. I can't quite reach to the edge. So that's not good. So I need to do that correctly. Now I also have a problem of reaching the back edge of the bed, which is not related to the zip tie issue. But that solution is basically to relocate the end stop switch up here. And I can either drill new holes and tap them, or I can come up with like a 3D printed adapter. All right, let's make all those things happen. Houston, we have a problem. Actually, we've got a couple of problems. First of all, this replacement bed here from TwoTrees is a 235mm square bed, but the TwoTrees Sapphire printer is only a 200mm square bed. So there's really no purpose to installing this larger bed because I will not be able to print to the edges. I can't even make it to the edges of the 200mm bed in the current configuration. So I think I'm going to save this nice glass print surface and use it on my Ender 3. Now this did come from TwoTrees, but it's sort of a beta test unit, and clearly it's not meant for the TwoTrees Sapphire 3D printer, this one here. So I'm just going to stick with the stock bed that came with it, and we'll just stay with this magnetic build plate solution that we've got going on. The next issue involves the top frame portion of the printer, and I was going to relocate these 2 holes here. These are the mounting points for the limit switch here, and you can see that limit switch cannot be drilled out, right? Those 2mm holes are really at their, their absolute extents. Like that's a very thin wall, so has to stay 2mm holes to mount this with. And I have the right drill bit. This was in my drill bit kit. It's the right size for pre-drilling out in preparation for tapping with a 2mm tap. But even here on my fancy metric tap set, I don't have a 2mm tap. The closest that I have down here is a 3mm. And I thought about drilling it out, but I just showed you guys that's not an option. So I can't drill that out and use a 3mm. So you can't buy 2mm taps at the local hardware store, Home Depot, Harbor Freight, any of those places. So the only place to get a 2mm tap is online. And that means you either buy it in America and pay like $8 so that it gets shipped to you in 4 days, or you buy it from China and pay 99 cents and wait 40 days for it to get shipped to you. Either way, I'm not going to get the tool in time to do this fix on this video, so that will have to wait. While I have this frame portion in this orientation, I do want to tell you guys that this carriage has no wiggle and it moves extremely freely. So they use some nice high quality linear motion rails along with the pulleys, the actual ball bearings themselves, because if they didn't use high quality, then there would be wiggle. But it's not perfect on the rails. This does not move very freely. There's a lot of resistance, and in fact, I can sort of feel like each little ball bearing. Basically, they just feel over-tensioned here on the 2 ends. Now, when I loosen all these screws so that there's a little bit of wiggle, it's free movement. So basically, these are just ever so slightly out of alignment is what it seems like, and there's no way to adjust these rails. I've taken the 4 screws out of this side of the rail so you can see that this carriage is just freely floating here. This crossbar is still attached by these 4 screws, and I have this Allen key there just holding the rail in place. But what's happening is you can see that gap down there. You see that right there? So basically, when I tighten these screws down, it's putting sort of twisting pressures on the little bearing cartridge here, and that's why the crossbar doesn't have free movement. If we take this top portion of the frame and we eyeball down the length of this edge, we can see that it's bent. So there's definitely a curve to that, which means that if I straighten this top plate out, I should get free movement along these two rails. And this is the setup that I'm using to straighten out that top plate. You can see I've got it just balanced here on the very ends on some scraps of 2x4, and then I'm slowly pushing on it, flexing it. Now I started with just a little bit of force, and then I checked it, a little bit more force, checked it, a little bit more force. You absolutely do not want to overdo this, or you could really kink and bend this badly. So patience and slowly ramping up to the correct amount of pressure is the way to approach this. But I've got this frame nice and straight at this point. Comparing to the main carriage, you can see just how easily that thing moves. These now have quite a freedom of movement, way better than before. Not quite as good as the main carriage, but I think it's good enough. So let's get this machine put back together. Okay, so the belts you can see are fully attached, crossing back behind there, so that they do not collide with the pulleys, and you see that the carriage is able to go to the full limits of the travel, which means that the nozzle is actually hovering off the edge of the bed, which is what you want. You want to be able to access that entire bed. Unfortunately, here at this side, the end stop switch there, you can see the switch, it's running into this little bump out portion of aluminum. So we just need to cut that off with a saw. I don't know why they included that, but it's preventing the nozzle from getting to the full extents on this side. But we definitely need to remove that so that we have more travel in that direction. Okay, so the next thing to do after we cut that off is to install the Slice Engineering Mosquito Hotend and all of the components. And when I say all of the components, that's really what I mean. Look at, I got everything. I paid a pretty penny for all of this too. So this is the high temperature thermistor. So it's not a thermocouple, but you can still get to very high temperatures for printing like polycarbonate, that kind of a thing. Here is the, what is it, a vanadium nozzle. So super high hardness nozzle, so I can print with carbon fiber materials without wearing out the nozzle. This is the boron nitride paste. That's the thermo-conductive paste, which will be really nice. And we've got this is just the electronics cable and the little fan. So we got all the fixins from Slice Engineering, including a couple of lollipops in the box. So we're going to get those installed right now. On the left, we see the hot end that I just removed from the printer. This is the least impressive part of the whole printer here. It's made with the usual suspects as far as materials go. That is an aluminum heat sink that's really poorly designed. Those chunky cooling fins do not go all the way through, and that's not titanium. That's just going to be some stainless steel on the heat break, and all in all, it's just super unimpressive. Contrast that with the most impressive hot end that we've seen lately. This is the Mosquito Hotend, and it's a lot smaller, but I was surprised when I first got it in my hands at just how hefty it is. So I went onto their website and had a look to see what it's made out of, and man, this thing is really intelligently designed. So aluminum used here on the heater block and the heat sink is, it has really good thermal properties, but copper has better thermal properties. So this heater block is actually copper. It's been nickel coated, and that nickel coating does two things. First of all, it makes it more scratch resistant and resistant to galling when you're putting your hot ends in and out of the thing, but it also reflects the heat back into the copper, so the whole heatsink just retains heat a little bit better because of that coating. So there's just so much like intelligent design in this tiny little piece of engineering, and I can't wait to get it on this printer to really run it through its paces and see if it performs up to its promise. Wiring up the hot end could not be any easier. I just clipped the original fan wires here on the original hot end and spliced into those with the new fan. I used the original heater element from the machine, and then I just clipped the wires going to the thermistor and spliced into those as well for this fancy thermistor. Unfortunately, we cannot use the fancy thermistor. Let me show you why. So here on the Slice Engineering page, we see all the details about this very impressive thermistor, the fact that it gets sent to 450 degrees Celsius, but it requires the update of the ADC table in printer firmware. So that means in Marlin, it's reasonably easy to do, and in RepRap firmware on the Duet board, it's extremely easy to update the ADC table. But on the Lurge control board, it's not even possible. So you can either choose between a K-type thermocouple or an NTC 100 thermistor, which, that's not the right type. So yeah, closed source bites us again. I've wired the original thermistor back into the board, and the screen is now giving us the correct ambient room temperature. Whereas with the Slice Engineering thermistor, that was reading only 3 degrees. Okay, now it's time to start thinking about how we're going to mount all of these components to the printer. So I've modeled up the control rail for the X-axis, and this is the X carriage, which moves up and down that rail. So we need to mount the hot end to the front of this, right in that position there. And the reason that needs to be there is because the tip of the nozzle here needs to reach the front edge of the bed, and this is the spacing that's needed in order for that nozzle to reach that location. So with the hot end placed there as required, we now need to think about where to put the BLTouch sensor, and I don't have enough room here on the sides because I cannot go beyond the edges of this bent aluminum piece. If you go beyond the edges of that, then we're limiting the travel in the X direction, which we don't want to do. So that leaves one location for the BLTouch sensor, and that is to put it right there in between the two legs of this bent aluminum piece, back behind the main hot end. Yeah, the next thing we need to think about is where are we going to mount the cooling fan. So I can't really place the cooling fan behind the BLTouch sensor. Otherwise, the BLTouch sensor would have to go through the middle of the cooling fan or something like that. I might be able to place it here vertically between the BLTouch and the hot end, Mosquito Hotend, but the technique I'm going to go with is actually to place it here on the diagonal. And I've used this technique on pretty much all of my builds so far. I really like it because it creates the shortest path of travel for the airflow coming out of these little tiny blower motors. Now these motors aren't very powerful, so you don't want to put a whole lot of ducting because that slows the airflow down a lot. And so by putting it so close, we get really good airflow at the tip of the nozzle. Also, putting it at an angle means that you need to turn the air less. It's almost blowing almost the direction that it needs to end up anyway. So less ducting and less turning of the air means better airflow. So this is, from an engineering standpoint, the best location for that fan. And it's not wider than the bracket here, so we're not going to have a problem with collisions to the front. I've checked for that, and so I really do think this is the best location. Okay, given that location, this is the bracketry that I've come up with, as well as the hot end. The part cooling fan duct there, which you can see is, like I said, really short travel, and we should get great 360-degree cooling right on the tip of that nozzle. So this bracket here, I'm rather proud of. It's just pretty minimal, should be plenty strong, and it prints without the need of any support material. Actually, all three of these pieces print without any support material, so that will make really clean and easy prints. I'm going to be making these out of polycarbonate just because I want a high temperature plastic, because I plan to enclose this printer. So higher temperature plastics that don't deform or deflect in the heat is the reason for the polycarbonate. Now, the final thing to note is the fact that I have chosen to use inserts. So these are threaded brass inserts. They come from the injection molding industry. You can purchase them over at McMaster-Carr or on eBay or anywhere else. And because the inserts are threaded, which means that the brackets themselves will receive the bolts. You need the bolts to go through these through holes, which you will have to drill into the bent aluminum piece here. Well, I don't know if you guys are going to be doing these upgrades, but I'm certainly going to have to drill these holes. And I've kept the two holes on each side in the exact same location from side to side. And this just makes my life easier. I'm not going to make a mistake drilling them and accidentally mount the hot end on the back side or something like that. So yeah, just keeps things easier. And it keeps it above the belts, because the belts need to mount into these slots here. So all told, I really do have some high hopes for this design, and I think it will work out quite well. It's looking good here in the computer, in the CAD space. So let's print it up and install it onto the machine and see how well it works. The prints came out really good. This is polycarbonate, so it's going to be high temperature resistance. And yeah, the assembly looks fantastic. I think this is going to perform really well. Putting it on the scale here, I just wanted to see how much things weigh. And we're looking at 87 grams. And that adds the BLTouch to the assembly, which wasn't on there previously. But here we have all these old components that I took off. But it's not all of them, because we still have this blower motor here on the new assembly as well. And we're looking at 169 grams. But when you add the blower motor in there, we're probably up to 188 grams, which means that's about 100 grams worth of weight savings here, and 100 grams is darn close to a quarter pound. So this is a McDonald's cheeseburger worth of weight savings. Awesome. And now what I've got to do is drill the holes here, 2 holes in the front and 2 holes in the back, so that I can mount these screws. To that end, I've printed up this little template, and I just line that up with the X carriage, mark those 2 little holes, and then that's my drill points. Okay, I've got those holes drilled front and back, but it turns out this is not aluminum, it's steel, and all by itself it weighs as much as the entire rest of the hot end combined. So eventually I will replace this, but for now we're just going to use this heavy piece of crap. And here's the whole assembly fully installed. I did not tell you guys before, but I basically put that little captive 4mm nut inside this little plate, and that's the Bowden tube threads into it. You've seen me do this technique before in my other videos. So it's a nice lightweight solution that absolutely has no movement in the Bowden tube. So very nice way to accomplish that task. Now you can see the BLTouch currently lit up, and if I turn the power off and then turn it back on again, we see that the BLTouch will go through its self-diagnostic. So that means that the sensor itself is functioning perfectly. And I've set it up in firmware to where the BLTouch should be the sensor that determines the Z height. So we're now bypassing the limit switch back here. We're no longer using that. And instead we're just going to use the BLTouch sensor right in the center of the bed. So it's just gotten to the end stops in X and Y there. And now it's going to try to come here to the center of the bed and do this Z. But you'll see that the BLTouch probe is not deployed. So it just does that garbage. Really bad. Anyway, if I want to solve these problems, the answer is pretty clear. I need to put a duet control board onto this printer. And so I will have wireless printing functionality, and I'll be able to get my high temperature thermistor to work so I can print at 450 degrees through the Mosquito Hotend. You can just see down in there. I think it's so cool that you'll be able to see your print happening through that little hole right there, and still get the nice cooling. By the way, check out how good the split cooling duct works. Really proud of that. And also I figured out over here that they want you to put the filament runout switch floating just like this. And so it can float up to the top here, or it can fall down, but it doesn't matter because when the filament runs out, this will just fall off, hit your desktop, you'll hear an audible noise that will let you know what happened, and also the firmware would supposedly pop an error. So I could keep that the way that it is, but I'm gonna upgrade that. And I'm going to accomplish that upgrade using the same technique that you guys have seen me use before on the Ender 3 extruder slash filament runout switch. By the way, if you haven't seen that project, it was fantastic. Go watch the video here. But I also used the same technique on the Tevo Little Monsters filament runout switch. So it just uses this optical sensor instead of the clicky switch inside of this one. So it's a much better technique, but it involves drawing up some geometry for use on this geared extruder. So I have to figure out how to mount that, probably replacing this lever or something like that. So I got to do some thinking on just how to accomplish that. But I'm probably going to end up drawing 2 versions of it because I'm also going to install this, which is a Zesty Nimble. So there's the hot end pieces, and then this is the cable drive that will actually spin the remote drive here. So we will accomplish directly driven filament extrusion, like having the stepper motor mounted directly on the hot end, but without any of the weight penalty, because you mount the motor stays mounted right here on the frame and it just spins this shaft. So a fantastically clever solution, and Zesty is a good company. You know, they get a lot of great reviews for their products. So I'm really excited. This will be the first time that I experiment with this product, and yeah, it should be good. I've been waiting for a good enough printer to install this on. I think I've had this for something like 6 months or maybe 9 months. This is the old version. So I'm gonna have to install that in the next video, as well as the Duet board. Why am I installing a Duet Wi-Fi $175 control board into this printer when it already has a 32-bit controller installed in it that works? And the main answer, the number one answer, is the fact that I can't get the BLTouch to work. Now, I did do my research and I looked into the documentation for the BLTouch, and I followed every instruction in that documentation to a T, and it still doesn't work. And the most rich portion of that documentation was the part where they criticize the BLTouch as not being accurate enough, which is hilarious. The BLTouch is just a really solid performer. So I guess they think that the best defense is a good offense. So if they criticize BLTouch, then you won't feel so bad for the fact that they know the BLTouch does not work with their electronics. So yeah, I want the BLTouch to work, but there's also the other issues which I raised in this video of the board being closed source. This is open source. This is the best board on the market, period. Like, nobody's arguing that. And I think it's well worth the $175, which makes this a much more expensive printer, but you know, in the grand scheme of things, not that much more expensive. This is pretty cheap. I remember when this level of printer functionality cost $35,000, just like 10 or 12 years ago. You had to get a Stratasys machine if you wanted to do this kind of work. So the DIY movement, or the RepRap movement, or whatever you want to give credit to, has really done wonders. And the fact that we think that $175 is, oh my God, too much to spend on your 3D printer is kind of ludicrous. So I'm happy to spend the money to do the upgrade. Okay, let's talk about these two test prints. The green one here was done using the Slice Engineering Mosquito Hotend, and the yellow one here was done using the original Hotend. So we'll get a close-up look at those and talk about them. But before we do that, I need to give a big shout out and thank you to these wonderful people. These are the guys who support this channel monetarily. Currently on Patreon, looking for an alternative, always looking. It's a lot of effort, and Patreon seems to have backed off of the thing that they were doing wrong. So maybe I won't leave. Maybe they've changed their ways. I'm hoping that's the case. So yeah, thank you so much to these guys. They are the reason that I make videos. Not even joking. Thank you so much. All right, let's take a look at these test prints, and then stay tuned to the next video when we do all of these other fantastic upgrades. Okay, here are the test prints. On the left is the original Hotend with a little bit of bowing on that bottom surface that peeled up on me because I tried to print it onto some masking tape, which didn't work out very well. Here in green is the test print from the Mosquito Hotend just now. Both of these are PLA material, and we're really not noticing any difference in quality between the two prints as far as the hot ends are concerned. Now, PLA, you wouldn't expect to see a difference. The way that the Mosquito Hotend is going to really shine is when we start printing the higher temperature plastics. They get a lot more difficult to print. So, but for regular old boring PLA, it's really not a necessary upgrade. I'll tell you the biggest thing that you notice difference between these two test prints is the part cooling. So here in the ceilings, as I turn them, you can see there's less drooping there in the green than there is in the yellow. And that's just because of that two-sided part cooling from the split cooling fan duct. And you get that directed airflow. You notice how it just droops a little bit less on the green. And then the other place you see that is in the spires. So here in the yellow, you can see the ugliness starts right about where my fingernail is there, and on the green, it starts up here somewhere. So let's see if I can give you guys a better view of that. Yeah, so you can see that there. It's minimal, it's slight, but cooling can definitely help in those two instances, ceilings and spires, which is why I have this test print set up the way that I do. Well, I have not been able to test the Mosquito Hotend thoroughly yet. I do have one complaint about it so far. This fan is very noisy. Hear how much quieter it is when I stop it? So, yeah, it's a tiny little compact Hotend, and that means that the size fan that they thought would match it is that little fan. And little fans always make more noise. So I think I might be able to make like a cowling duct that will take the Noctua fan that I have and mount it there, and that should quiet this printer down quite a lot, because this is just unpleasant to be working in the same room as this printer with all that noise.